Question number 8, part A. This is a question related to light waves. So over here, there's a diagram that we have. We have a boundary over here. The above part in the diagram is ice. So this whole area over here is ice and the below part over here is air. We have a light wave that is going like this in the direction of the arrow. I have drawn the arrow because these are the wave fronts. So this over here is a light wave. Now, we have been given the speed of light, which is c equals 3.0 into 10 to the power 8 meters per second. And we have also been given the refractive index, which is 1.3. So, I'll just write refractive index indicated by mu, which is 1.3. Now, let's read through the question. Part 1. Draw the wavefronts of the wave that passes into the air. Okay, so this is related to refraction. Then we very well know that if we have an incident ray like this, it will enter through the material and go in this direction, somewhat like in this quadrant. Now how will it go? We can see that it is coming from ice to air. So ice is more dense than air, therefore it will bend outwards from the normal. Therefore, I think it should go something like this maybe. Okay. One more thing to notice is that while it is bending, it is also going to a different medium, this time to air. Therefore, the speed will be higher. Because the speed of light is higher, we have to draw wavelengths which are more far apart. So the wavefronts will be more far apart compared to this diagram. I will draw the new diagram now. We get a wave that looks something like this. Okay, fine. So coming to part 2. Part 2 says draw arrows to show the direction of travel of the refracted wave. That is something we kind of have already done. The direction is this one over here. So I'll just draw one arrow which will look like this. Moving on to part 3 of the question, we have been asked to label the angle of incidence I and the angle of refraction. Okay, so the angle of incidence will be the angle between the incident ray and the normal. So this one over here is the angle of incidence. We'll write it angle I. And this one over here is the angle of refraction. One more thing to note is that angle of refraction will be greater than angle of incidence. Let's move on to part B. In part B, we have been asked to calculate the speed of light wave in the ice. Okay, we have been given the refractive index. The formula for the speeds is refractive index is equal to speed of light in vacuum, which I'll call c, divided by the speed of light in the material. In our situation, this equation becomes 1.3 equals, using calculator, we can find that we shift v to here and 1.3 comes down. V equals 2.3 into 10 to the power 8 meters per second.